Hi everyone. I hope that you can hear me. I have no idea if I've done the technical stuff okay. I think I have. Hopefully, if there's anyone out there and they can hear me, maybe just put something in the chat. I hope you guys are doing well. Maybe no one. Maybe you guys can't hear me. I think it's okay. I'll just keep on going and do the lesson, and then hopefully I'll get some feedback on the chat whether all of the audio and all of the visual is doing okay. I think with the visual we're okay. The only thing I'm worried about is it might be a bit laggy, that's all. But thanks for viewing this live stream. I think I'm really hoping to do more live streams because they're nice ways to be able to get back to viewers regarding issues that are important to them, to get back to them in a timely manner. Because if you watch any of my stuff, it takes me a while to get things done, and especially if it's a complicated topic, or it's a little bit more complicated than standard, then sometimes it can take me a while. So today I'm going to talk about the difference between a Slutsky and a Hicksian substitution effect and normal and inferior goods. And that brings us to the topic of a Giffen good. And then I'll go through a practice question from Varian. And I feel like, yep, that's okay. Sorry, I just heard something in the background, which I think was my own voice from the live stream. Okay, so let's start. And I wanted to start, I've got notes for myself all the way through, and I just wanted to start with a rough discussion. And sorry if you can hear my dogs in the background as well, my various comings and goings, but a rough discussion on what we're doing when we're thinking about income and substitution effects. And really the idea is that the law of demand, or when we learn about demand curves, it's always this downward sloping thing, right? There's a negative relationship between price and quantity demanded. So if you increase your price, quantity demanded decreases. And really the idea of income and substitution effects is that we want to understand what's going on underneath this kind of classical movement. If we think about a price decrease, a decrease in the price of a good, the idea is that there's kind of two distinct things going on. And I think it's just, and the reason why I've put here in my notes to talk about it roughly or intuitively is because when we talk about these two different effects, it is rough. It is not certain. And that's why different people have come up with different ways of understanding substitution effects. So the idea is that if the price of a good decreases, let's say tomatoes, I was thinking about tomatoes, the price of a good decreases, there's kind of two things going on. The first thing is that the price of tomatoes, I'll say example tomatoes. Sorry, that's my dog sneezing in the background. I don't know if you guys can hear that. Example tomatoes. So let's say the price decreases for that good. The first thing that happens is tomatoes is now cheaper relative to your other goods. And we always learnt about it, but I was looking at this in Varian, and he doesn't talk about it like this, but essentially the opportunity cost, right? The opportunity cost of buying a tomato has decreased. Tomato has decreased. Because when you buy a tomato, you're taking less out of your income kitty, so you can you're not giving up as much other goods. So that's the first kind of effect, and we're going to talk this about the substitution effect. Substitution effect. And the idea is if we had, I'm guessing you guys who are inevitably going to watch this, there's the idea of a budget constraint this our budget constraint. And I've done videos on this if you need help with that. And say we had X1, X2, this was tomatoes and this is all other goods or something like that. The slope of this is the price ratio of P1 over P2. So when you change one of the prices, holding everything else fixed, the slope of your budget constraint will change. So the slope changes. And that's really this idea about the way we're substituting between two goods as we're consuming more or less of them, that's changing. So that's a substitution effect. The second sort of thing we can see is going on is the income effect, which is the change in the purchasing power as a result of the change in the price of a good. So change in purchasing power. Now, nominal income has not changed. So we're not changing our income. But now our income can buy more of lots of different things as a result of the price decrease of tomatoes. So change in purchasing power. Purchasing power. And this is going to be our income effect. Is that our real income, how much our income can buy, changes as a result of the price of different sorts of goods changing. So that's income effect. Okay, good. Right. So the worry is when we think about changing the slope of our budget constraint, we can change it in lots of different ways. The slope changes, but where do we put it? What level do we put it? And at what level do we capture this idea of a substitution effect? So that's the idea of, there's kind of two different ideas about what we should do there. And that's the difference between Hicksian and the Slutsky decomposition. So let's do the Slutsky decomposition first. Oh, hello. Yes. Question. Hi, Simon. Simon? Or Simonu? I'm not sure. When the income changes, will there be only an income? Yes. Yes, so if you just had... So that's a really good question. So the whole idea of substitution and... Where is this? Here. The whole idea of substitution and income effect is what happens when the price of a good decreases, because we are trying to understand this demand curve here. So that demand curve changes prices and quantity changes as a result, kind of holding everything else constant, but we're holding everything else constant. So the income and substitution effects is specifically trying to understand what happens to a good when the price of that good changes. When income changes, you're just going to shift this budget constraint out or in, and that really we don't talk about an income effect in that sense, because the idea of an income effect, well, at least for me, but maybe we're getting to semantics here where different people teach it differently, but maybe for me the income effect is really reserved for this idea of a substitution and income effect that occurs because of a change in price. Does that help? Let me know. And then, yep, so when income changes, no substitution effect. That's right, yeah. Yeah. Okay, good. Thank you for turning up. Let's go into the Slutsky. And I don't know how much of a lag you've got. I think it's okay. I think it's all right. All right, let's do the Slutsky decomposition. So I hope this is familiar to you. We just have this idea of optimal choice under constraint for consumers. So we have our budget constraint. If you're in a exam, I would be labeling things more properly than what I did here. You would put your indifference curves and budget constraint, etc. And if you had actual numbers, put those in as well. Because it's so sad when people lose marks because they haven't labeled things properly. Okay, and let's say that the price of good X1 decreases. So the budget constraint is going to pivot. And we still have the same income. And I will write up here, if you remember, if you saw or if you've studied kind of the idea of a budget constraint, what are the important equations we have here? We have our income, as long we're always exhausting all of our income. So we're purchasing, our income is equal to the price of good 1 times how much X1 we've got plus the price of good 2. And that's fine. That it pivots means that this income isn't changing. We can still buy exactly how much X2 that we could before, no more or no less. So this income is not changing at all. So this shift represents a decrease in the price of good 1. So I'll write that decrease in the price of good 1. And what I think I can do, as long as everything goes okay with the recording, I can probably just PDF these notes and add them to the recording later. If you wanted to, then you can download them. You don't have to worry about copying things. Good, so we have our initial choice and we get X1 star. And then the price of a good 1, that decreases, and we get a new choice. Where is my indifference curve? Oh, I think I've lost my indifference curve. It's okay. I'll make another one. We have this one. And we're going to get those points of tangency. And the idea of income substitution effects is that we can divide up this kind of total change in X1. We've increased our consumption of X1. We can divide up this total change into 2 distinct parts, our income and our substitution effects. And what Slutsky is going to do is he's going to, and I'll just take that away, he's going to think, remember that the substitution effect is all about the change in the relative prices of the goods. So we tend to substitute towards the cheaper good, So when you change 1, that slope changes, that P1 over P2 changes, and we've changed it to here, right? We have the new thing. And I was thinking, and I think that this is his reasoning. What he does is he changes the slope of the original, which is fine, but he makes the new slope so that the old bundle is just affordable. So he's going to understand we're going to have this kind of imaginary, or let me just get this one in, let's say pink. We have, with this budget constraint, we have the new price ratios. And I said before, the idea about the substitution effect is like, okay, we're going to change those price ratios, but where do we put this line to measure the substitution effect? Well, I think what's happened with the logic here is saying, look, our income effect only is all about purchasing power, is all about how the change in purchasing power changes our decision or factors into the change in the demand for X1. So what I'm going to do is that I'm going to change the rate at which, change the price ratio, but keep the purchasing power constant. So how do we keep the purchasing power constant? Well, we make the bundle that was preferred before just affordable. So the idea about the Slutsky decomposition is that we always pivot and shift, but we pivot around the old bundle. And then, theoretically, that kind of theoretical budget constraint, we'll hit an indifference curve, and there will be a tangency point, say X1 prime, and the difference between the old X1 star, the original, and that theoretical X prime one, that will be the substitution effect. And then the rest of the effect is the income effect, which is X1 to X2. And that's really, if I've got my pink line, let's grab my pink line. Excuse me, sorry. There. That's moving that up to its place of the pivoted budget constraint. So that's the income effect, which goes from here to here, here to here. So that would be a standard normal good. I'll just check the chat. Okay. So the new budget line, we shift it into the old indifference curve. We see, actually, that's not quite right. The new budget line, so do you mean the black one or the pink one? So the new budget line, we shift it into the old indifference curve. So when we think about Slutsky, when we think about Hicksian, we do move it along the old indifference curve because we hold utility constant. But when we think about the Slutsky decomposition, we're going to shift it around the original bundle. I'll show that once more time. So it will be here. So we start from here. We have the black line is the new price ratio. So we shift to that new price ratio because that's the substitution element. But we're going to shift it around. We're going to keep purchasing power constant with the Slutsky decomposition. So we're going to shift it to that's about right. But we're going to shift it around this point here, this blue point, which is that original bundle. So we evaluate what would happen if the budget line was like this. That bundle that we were originally purchasing, that's still the bundle, that's still affordable on our budget line. So we keep the purchasing power constant. Just affordable as well, just affordable. But we think, okay, well, what if the rate in which we were trading off between these two goods, the price ratio, if that changed but the purchasing power was constant, well, what would we be choosing then? Well, we think about this budget constraint, and then there is a theoretical indifference curve that lies tangent to that budget constraint. And that point of tangency, that would indicate the X that we would purchase if the prices were different but purchasing power was held constant. And so the difference between the original X1 star and X1 prime, that's the substitution effect. The old indifference curve. The black, we move it to the old indifference curve. So the new budget line, we shift it to the black one is just, the black one, that's right. It's like the black one is fine. That is, we know what's happening with the black one because we view that decision, like we view that choice. And so we shift that. This is kind of theoretical. What would happen if we changed the prices but left purchasing power constant? And then, the idea is that we would then shift, I've got one here, out to the black. And that's indeed, there is theoretically many of these. But we just leave that as is. Please let me know if that helped. All right, so this would be a normal good. This would be a normal good. Let me show you a different case. What would happen? Apologies. Okay, we're going to have a similar Slutsky decomposition. We start from an initial point. We have our choice that we make at this price ratio, this level of income. And then our prices change, and so our choice changes. Okay, we're going to try and understand what's behind this change in X. So we conceive of a new budget constraint which has the same trade-offs, the same price ratio as the black line. That's and I shouldn't say new because the new one is really the black, but the green one is, we conceive of an imaginary. We think, what if? It's very kind of imaginative, isn't it? So the green line is if we change the price ratio, but we kept purchasing power constant. So we pivot that budget constraint over the blue bundle. So we make sure that bundle that we were originally consuming, that's on that imaginary budget constraint. So we keep that bundle just affordable. And then if we had that budget constraint, then there would be some indifference curve to which it was tangent to. And you can see here that substitution effect is very large. Okay, it's very large, and it actually oversteps the final choice. So what's happened here? Let me just check oh, you got it? Is a price increase common or mostly decrease? I think that most books do that. It's a good question. I'm glad you got it. That's good. Very good. Is a price increase also... mostly we do decreases. And I was thinking because Giffen good is best explained with a decrease. And it's kind of funny because I think it's easier to draw with a decrease. So I think that's why always it's a decrease. And I haven't got one. I didn't get to drawing one where it was a price increase. But you guys should probably practice that just in case they give it to you in an exam. But I think it's because it's kind of easier because we start from something small and then we move to something bigger. So it's kind of easier just to draw. It's just easier to think about a price decrease. But yeah, we can talk about a price increase as well. And note as well, and this might be part of it as well, because we always evaluate things, when we have our demand curve, which is this whole thing is just about the demand curve, right? We're always going from the origin out to the right. That's how we evaluate things. So that corresponds to a price decrease. So maybe that's the reason why as well. But yes, we can conceive of it the other way. Good question. Okay, so if we had something like this, then the income effect is negative. Can you guys see that? Because we pivot this green line, this green hypothetical budget constraint, and we get something that oversteps the new choice. So the income effect is negative here. Where's my green line? There it is. So when we put it out, we actually get to here, and X, the income effect is here. I've got them written out. There you go. So the total effect is here, is less than the substitution effect. And so what's happening? There's a negative income effect, and that's characteristic of an inferior good. Now, if you remember inferior goods, there's a few ways we kind of talk about it. We talk about it in terms of income elasticity of demand, which points to a general thing, if our income increases, then we buy less of it. That's an inferior good. So we do talk about inferior goods in this way, but we also talk about inferior goods in this way, where the income effect, that's the change in purchasing power, there's a negative relationship between how the income is changing. So note here that the purchasing power has increased, but the income effect is telling you to buy less of this stuff. Does that make sense? Let me know if that idea of an inferior good. So there is a few ways we talk about it. One is just if our income increases, and there we have kind of our income elasticity of demand. If you guys are familiar with that, definitely I've taught a lot of courses where that's the first year treatment of it. But then this idea of an inferior good, where the purchasing power is changing. So the income effect, not the income, but the purchasing power has changed. All right, well, let me know if there's any, if that's okay. That's an inferior good. All right, so that's the Slutsky. And I don't know which one you guys are learning, because often they just talk about one, which is often the Hicksian, which is this one. So hopefully I haven't confused you. I mean, it's nice to see the whole picture. Varian does the whole picture. Are you guys using Varian? Is this there's this it's kind of a classic text variant, and he goes through both types, but a lot of really good texts as well, they just do one. But then it's really confusing for you guys, right? Because you look at different textbooks and you get different stories about what's going on. The Hicksian decomposition says, remember the question, is I'm going to change the slope of our budget constraint to be equal to or to represent the trade-offs associated with the changes in prices. But the problem is, what happens to, where do we put this? So that this line would represent the right trade-offs. But, what do we do? Where do we put this? And so Slutsky went, well, we hold purchasing power constant. So we pivot it around on the old bundle. So we make sure that old bundle is still just affordable. And Hicksian, and this is the one I've done a video on, Hicksian will be just, you keep utility constant. You keep utility constant. So you pivot it around the original indifference curve. And that will be once you get that kind of hypothetical budget constraint in here. And it's just a difference in interpretations, really, of what it is to be a substitution effect. So you had substitution effect here. The total effect is here. Total effect. And then the income effect would be that residual, that, income effect. Let's see. Yeah. Then when we have, so because when M increases, X decreases. We have an inferior good, yeah. Oh, yeah, that's for a Giffen good. I don't know what a common good is. What's a common good? I'll have a think about common good, but what's EE? Can you let me know what EE is? When we have an inferior good and the price increases, income effect, yep. Oh, really? I really like the German language. I used to have a roommate that was she was German, and she used to talk to her parents, and it's a very nice language. Okay, yes. Okay, when M increases, X decreases, that's inferior good indeed. But then when we have an inferior good and the price of good one of that good increases, well, you would decrease you'll decrease the consumption of this good. And have to compare the absolute value of the... let me just draw it out. And Simone, are you doing it with Hicksian or Slutsky? I can draw it out. Let me just show you what the income effect with the Hicksian, because the Giffen good, you do have to compare the magnitude of these things. But a Giffen good is just a very inferior good. Okay, so this one, any case, everyone is okay with this? That's a substitution effect. So this is a Hicksian decomposition with a normal good. And then we can do the Hicksian decomposition with an inferior, and it will look like this. This one. See, what I've done, this hypothetical budget constraint is pivoted around the indifference curve. The substitution effect is quite large, but you can see that we're going back. I will just go through them. The income effect is negative. That's an inferior good. All right, I'm going to have a look at this chart. We have an inferior good and P1 increases if it is a Giffen good or a common good. Okay, let me go through the Giffen good stuff, and then maybe that will help. All right. Yeah. Giffen good's a theoretical possibility. I think I've got it here. Okay. Okay. So here I'm just doing the Slutsky decomposition of what would be a Giffen good. And so what's happened is that the total change is, this is again a decrease in the price. I can do an increase in the price in a second. In the price. Okay, so we've gone from this budget constraint to this budget constraint. We have our hypothetical budget constraint, which holds purchasing power constant, depending on what you're doing, whether it's Slutsky or Hicksian or whatever it is. It's the same for Hicksian. I'm just doing a Slutsky here. So we get to a new, and of course the substitution effect is always going to be in opposite direction to the price change, right? So the price decreases, we're going to substitute towards that cheaper good, so that the kind of effect is positive here because we've decreased the price. But you can see that and you can see it's so hard to draw with the indifference curves, and I see this in different places. You just in the end up doing these little ones so they don't cross each other. But this is a Giffen good. A Giffen good is really, really, really inferior. So much so that the price of good, see what's happened here? This is why it's a theoretical kind of possibility. The price has decreased, but and quantity is decreasing. And this is against our law of demand. I mean, there's different ways to understand the law, to express the law of demand, but most people just say there's an inverse relationship between price and quantity. As price decreases, quantity increases. But here we have a positive relationship, not an inverse relationship, which is possible with a Giffen good. So from x1 to x2, that's the substitution effect. What's happened with the Giffen good? It's very, very inferior. So the income effect is huge. It goes from x2 to x1 star. This is the income effect. Okay, I'm going to look at chat. Oh, okay. Maybe they're just saying, yeah, okay. So if a common good is just a relationship between the direction of the price change and then the direction of the change in X. So it's more about the substitution effect. I see, I understand. That's just a discussion about So Simonu, how's that for a Giffen good? And in this case, we are comparing the magnitude of the substitution and the income effects, specifically if the magnitude of the income effect of the negative, and it's going to be negative income effect, if that is greater than the magnitude of the substitution effect, then theoretically we have a Giffen good. Yes, it's okay. So everything's okay? Yeah, that's what it is. It's just so it's just so so inferior. That's the idea. I think the common good is that's just what's happening Oh, I see. That's what they mean. Yes. Okay. Yes. Yep. So maybe the common good, that's more about, oh, sorry, that's my water with my coffee. I see. So this is more about the direction of the relationship between price and quantity demanded. I think that's what they must be doing for common good. Yeah. So if so maybe the common good, this negative relationship between price and quantity demanded holds, but for an uncommon good or something, whatever that is, or giffen good, it's the only possibility for a negative relationship, a positive relationship between price and quantity demanded. Yeah. Okay, good. I have 10 more minutes. I was going to go through a practice question just from Varian. Is that what, or I'll give you, anyone wants a question or a clarification on any of this stuff, let me know. So I'll just go through, so this sort of question is a common one that you can get in exams, and it's really, so this is, Simona, I've lost track. Was this you? Was this one? Was this, were you the user who emailed me this one? Anyway, let me know if that's all okay. All right. Oh, that wasn't you. Okay. That's okay, because you're asking the same sort of questions as like someone else. Yeah. All right, so I'll go through one question, and this has got to do with the Slutsky decomposition. This is just really a sort of question that you might get to test our understanding. I don't know. Are you guys using Varian? Let me know if this is completely not relevant to you, and I can stop. Okay, so gentle Charlie, a vegetarian that he is, continues to consume apples and bananas. There must have been another question before this about Charlie. His utility function is here. We've got Cobb Douglas, very simple. The price of apples is 1, the price of bananas is 2. Charlie's income is $40 a day, and the price of bananas falls to $1. So again, we are evaluating here a price change. My texts are in German. Huh. Oh, I see. Yeah. Okay, that makes sense. Good. So we have good. All right. Let me get my notes so I can remember what I was doing. Actually, they're pretty good. They're pretty good little exercises in Varian. Okay, so before the price change, Charlie consumed how many apples and how many bananas per day? So here we're just going to use, I know this guy is an interior solution because, utility is equal to, if any one of these is 0, then utility is going to be 0. So we know we're going to consume both of them in positive amounts. So it's going to have an interior solution, which is characterized by that MRS, which is MUA, marginal utility of A over the marginal utility of B is equal to the price ratio PA and PB. I will also just write here PA is equal to 1 and PB is equal to 2 initially. That's what we're thinking about anyway. So the partial derivative of our utility function with respect to XA is equal to XB. Are you guys okay with that? Oh, okay, I've got another question. When we have a normal good, is the substitution effect and income effect always negative? So the substitution effect, if you have a normal good, substitution effect will always go in the opposite direction to the change in the price. Always. It doesn't matter if it's a normal good or a or an inferior good. The substitution effect is just how we relate to that change in relative value, relative prices. So if the price decreases, then we will substitute towards that good. So the price decreases, and now we will want more. So X will increase. So the substitution effect is always negative. It's always an inverse relationship between what's happening with the prices. The income effect will be if the price decreases and we have a normal good, then then that will be, indeed, that will be negative as well. So that's a correct statement. Yes, good. All right, so we have the partial derivative of utility with respect to A. So, this is implicitly to the power of 1. So bring this guy out the front, which is just 1. Take 1 off the exponent and you get 0. So it's just 1. So xb. And very easy. B, the partial derivative of utility with respect to good B is A. And then we can substitute these are our marginal utilities, right? So we have xb. So therefore, xa is equal to 1 over 2. We can just solve for either. So xa is equal to 2xb. This is the ratio in which we're going to be consuming these goods at the optimum. We have our budget constraint, which is our income, which is 40, is equal to, I'll just do it abstractly first, the price of A times how much A we consume, plus the price of B times how much B we consume. So substituting the values, we have 40 is equal to, the price of A is 1 times XA, so just XA, plus 2 times XB. We substitute in our optimality condition into our budget constraint. So I just write here, this is the budget constraint. So 1XA is 2XB, so we can substitute in, we get 40 is equal to 2XB plus 2XB is equal to 4XB. So 40 is equal to 4XB, so XB must be equal to 10. That's 40 divided by 4. That's good with everyone? Yeah. Okay, so we can substitute. So if XB is 10 and XA is 2 times XB, then XA must be 20. I think that's right. That's what I got before. Must be it. So that's how much we produce before that we... that's how much we consume. Charlie consumes 20 apples and 10 bananas per day. So we can think about a diagram here. Here we go. B, bananas. A, apples. Let me think. Got it here. I see. So our intercept is going to be, for bananas, is like if we only bought bananas, how many could we buy? Well, bananas are $2 and we have $40. So we could buy 20. Okay, and our apples axis, I'm going to put that lower. I regret that. There you go, that's better. Our apples are $1. We have $40. So M is 40, right? Where's that? I'll just show you. That's there. So M is equal to 40. So if we only spent all of our income on apples, we could buy 40 of them. So that's our, there, I'm running out of room. There we go. Sorry, I sniffed. I'm trying not to. I woke up with a stuffy nose. It's so cold here. My gosh. Okay, so that's our budget constraint. And we found that that's going to be our place, our good place, where A is equal to 20. XA is equal to 20 and XB is equal to 10. So good. If after the price change, Charlie's income had changed so that he could exactly afford his old consumption bundle. So this is the bit that I really wanted to do, because this is the bit that's like, that's that Slutsky decomposition. We are thinking about if after the price change, Charlie's income changes so that he could exactly afford this bundle, but with the new prices. His new income would be, so the idea is that when we change to a steeper slope, which will be that it will be like this, right? After the change in bananas, our slope will be like this. That will be the new one. But what we're going to do, and here it's different, it's different because we're changing the price of B here, not A. Before we did it on A. Let me check this. Are we good? Very good. So there, what the question is asking us is, if we have that new price ratio, which will, the price of B, that's, let's just call it the price prime of B is equal to 1. It's the decrease in price. So now if we spent all of our money on bananas, we can spend 40. The question they're asking, if the slope changed, but we can still only just afford that bundle. So that's that Slutsky decomposition. We're holding our purchasing power constant. How much would the income change? So he's basically saying, if we pivoted the budget constraint so it had that new, what actual nominal income would that correspond to? Because that's the line of that hypothetical budget constraint. So I'm just going to do that. And how do we do that? Well, we know some things about this line. We know that about this red line. Actually, I'll do it in green. It'll probably be better. This green line, this hypothetical Slutsky, decomposition. We know that the price ratio, the slope, is now equal to 1. And we know that this point, 2010, is on that. We know that original bundle. So what we need to know is, and I'm so sorry, I'm going to have to go pretty soon. So I'm just going to take that off and just do this last bit, where I find the value of this line. So how do I find the equation of this line, essentially? How much do we have to change income, essentially, to get this equation of this line? Well, I know that this line has a slope of 1, and I know that this point 2010 falls on this line. So we're looking for the income, M prime, that sometimes we call it compensated income. We're compensating for the price change, but we're holding purchasing power constant, is equal to, well, the price of A is 1 times XA, and I'll just do it, plus, I'll just do it abstractly so you know, and PBXB, right? We know that we need to find M prime, and we know that this line 2010 falls on it, so we can substitute our known values in. So the price of A is 1 times XA is 20 plus the price of B is 1 now, because we have that new slope, and the XB is 10. And that will give us our M prime. M prime is equal to 30. Let me see how we're going, because I don't even know if this is relevant for you guys. I don't know. Okay, I can just multiply the new price with the optimal XB. Indeed. Yeah, that's it. Well, like that would be the change in M? Yeah, no, that's right. Yeah, you can. Yeah, indeed. Very good. So that's our revised income. I think so. Yeah, I think so. Yeah, I think so. If it works, yeah. My brain's gone. So if it works for you, I mean, the other way they do it is the change in M is equal to the change in the price times X B. That will be the change in the M. Then you can change it from there. I don't know if that's what you're talking about, but if it works out logically for you and you understand it, I'm sure that it's correct. Okay, so his new income would have been 30. So we're saying for this line that corresponds to a nominal income. We've kept purchasing power constant, but that's 30. With this income and the new prices, Charlie would consume how many apples and how many bananas. We can use our, the condition that we had here before, and it will be like this, right? But the price has changed here. So XB, and I'm sorry, this is too fast for you, but XA, because that price 2 is now price 1, but it's the same. It all makes sense because in our utility function, you can see that there's a symmetric relationship between XA and XB, right? I don't know why I have a 1 there. I'm sorry. That's confusing for you. Hopefully that's not too bad. But, there's no difference between them. So there's no difference between them in the utility function or in the prices, then they must, this is expected. This is to be expected. So then what happens? We end up consuming 15 of each here because we can substitute this into our budget constraint, which is 30 is equal to XA plus XB, but XA is equal to XB, so it follows that XA is equal to XB is equal to 15. So what we're saying is that we pivoted that line, and at the new optimal for that new line, they're both 15. I think I did it too. Something happened. XA. It's here. It's just not very. It's not very to scale. I feel so sorry for you guys having to do exams, because sometimes to work out the optics of how these things have to look, it's a bit hard. 15 apples and 15 bananas. Okay, very good. So that's finding that so then the substitution effect in this case would be 5. And then we know you can figure it out for yourself. I think eventually at the new income, at the new budget constraint, this red, I think it's 2020. So then the income effect is 5. But I'm so sorry, I have to go now because I've got another thing. Oh yeah. Did I make sense, or it was kind of a bit different? Okay, I gotta go, guys. So if you want me to do another live stream, or that's all right. Thank you for coming. Let me know. I'll probably try and do one. I'm on break for a little bit, so I can do one for a week for a little while, or I might do something. Oh really? Okay, that's great. I mean, I think I got 7 views all up, which is not so bad. But let me know topics. Maybe I'll put something in the community tab, like a range of topics that you want, or if it's more of this sort of stuff, or yeah, I don't know. Okay. Thanks so much, guys. I will PDF this stuff, and once I put it live, I don't know whether I'll put it live straight away. What I mean by live is post it. Oh, Monopoly. Really, Monopoly. Okay. You can always email me, econmathhelp@gmail.com. If there's with the sorts of material that you'd like me to cover, and then so I'll probably do one next week as well, but maybe not Thursdays, because I realize I've got this thing on Thursday morning that I have to go to. All right, see you guys. Have a good one. Thanks for coming. Bye. God bless you too. Bye.